Okay, so for this question we're trying to, sometimes we're given the complex numbers in polar form and we have to write them in rectangular form, and then other times we're given them in rectangular form and we have to write them in polar form. Now to convert this one backways, just remember that pi is equal to 180 degrees, and my advice would be to change that straight away. So it's going to be 12 cos 180 over 6 plus I sine 180 over 6. And what you can do there straight away is put these parts into the calculator. So it's going to be 12 by root 3 over 2 plus a by a half. Or people generally write it as a half a, it just makes a bit more sense. So then this answer is going to be 6 root 3 plus 6a. And that is my final answer. I've written it in the form x plus ya. Second one, same idea. Remember pi is 180, so it's going to be 5 cos 180 over 8 plus a sine 180 over 8. Now to speed up the process, what you can actually do is multiply the 5 in here, multiply the 5 in here. So when you're putting in the calculator, you'll put in 5 cos 180 divided by 8 straight into the calculator, and you'll get back your answer. Sometimes you'll have to just write them in decimal form, so it's 4.62, and then do the exact same thing for the sine. So just change the cos to sine, and you'll see that it's 1.91. So it's plus 1.91a. Now this is the most important part of this example, being able to represent a complex number in polar form. So first thing we need to do is represent it on a Argand diagram. So we're going to plot it approximately where it should be. So we've got minus 1 and then we've got root 3a. First thing we need to do is plot the point, then we need to find the modulus. In order to find the modulus, it's going to be the square root of a squared plus b squared. So that's what r is equal to. So then it's going to be the square root of minus 1 squared plus the square root of 3 squared. Put that in the calculator and you'll get back your answer. So r is equal to 2. Then we need to find the argument. We need to find this angle here. Now really and truly what we're trying to find is the angle from the positive real axis right around to that point. But in order to do that, we need to find the smaller angle first and then take it away from 180. So we know this distance is root 3, we know this distance is 1, so then it's going to be tan q is equal to opposite over adjacent. We're always going to use tan, remembering back to trigonometry. So then it's going to be the tan q is equal to the root 3 over 1, q is equal to tan inverse of root 3 over 1. Put that in the calculator and you'll get back your answer, which is 60 degrees. Now that isn't my final answer, this is just a small angle here. Remember we have to find the angle from the positive real axis right around, so it's going to be 180, take away 60, which is equal to 120 degrees. Now to write that in polar form, so it's going to be r cos 120 plus a sine 120. If I wanted to get it back to rectangular form again, you would multiply 2 by cos of 20 and then 2 by sine of 120, and you would get it back into rectangular form again. Just looking at a second example very quickly here, we can plot the point in an Argand diagram first of all. So it's going to be over 1 this time, and it's going to be down minus root 3a. So we're going to go down minus root 3 here, plot the point. Again what we're going to do is find the modulus, the square root of a squared plus b squared, and you're going to get the exact same answer as the previous question. It's going to be 2, so that's your modulus. Then to find the argument, we're going to find this angle here, but remember we have to find the angle from the positive real axis right around to this point, so it's going to be 360, whatever, take away whatever our angle is. To find that, you're always going to use the tan, so it's going to be the tan q of opposite, which is root 3, over the adjacent, which is 1, so q is equal to the tan inverse of root 3 over 1, so that is equal to 60 degrees. To get my full angle, it's going to be 360, take away 60, which is equal to 300 degrees. So then when I'm filling it into the formula, it's going to be r cos of the angle plus a sine of the angle. Again, if I wanted to transfer that back into rectangular form again, put 2 cos to 300 in the calculator, and then sine 300 as well into the calculator.